Consider the function given here. Determine the equation or equations of any asymptotes of f of x. Now we can see straight away by looking at the denominator that x equals 1 is going to be a vertical asymptote. X can't take the value 1 without the denominator being 0. The numerator is of higher degree than the denominator, which suggests an oblique asymptote. Now we could get at that by division. So there's no x's there. So x into x squared goes x. X times x is x squared. X times -1 is minus x. And then we'll subtract, and that would give us x plus 2. X's into x goes 1. And then 1 times x is x. 1 times -1 is -1. And subtract is 3. So that tells me that y is equal to x plus 1, because all we do here is look at the quotient, is an oblique asymptote. Now also we can write f of x now as x plus 1 plus the remainder divided by x minus 1. So when we're asked to find the exact x coordinates of the turning points, it might be easier to differentiate this one. That's going to be 1. And remember that this could be written as 3x minus 1 to the -1. So take away 3, x minus 1 to the -2. So that's 3 over x minus 1 squared. So if we're interested in turning points, that would mean that x minus 1 all squared would be equal to 3, because then we'd have 1 take away 1. So x take away 1 would be plus or minus root 3, and therefore x would be 1 plus or minus root 3. We're now asked to sketch the graph. Now think about the fact that root 3 is about 1.7. So that's going to put these at 2.7 and about -0.7, just roughly. Just keep that in mind. So we know that the vertical asymptote was x equals 1. So let's put that onto the graph. So what we have here is x equals 1. The oblique asymptote was y equals x plus 1. So that is going to be this line just here. And continuing up there. So that is y equals x plus 1. Now we know that one of the turning points was at approximately 2.7. So that is going to put it around here somewhere. We don't need to know the exact y value. The other one was at -0.7, so that will put it in here somewhere. Now the only thing that our curve can really do is this. Now there are other tests that you can do to make sure that it's in these parts, but it's going to go like that. We might want to get the y-intercept accurate. So if we go back here, put x equal to 0, and we'll find that it's -2. So that's here. So that is going to go along this asymptote. It's going to have a maximum there, down through -2. and it's going to go down like that.